We good to go?
Not quite yet.
Awesome. All right. Hello, everybody. How's everybody doing today? Good, good. Well, welcome to Space Place Canada's exclusive event and expert-guided discussion, Sun Meets the Moon, Cultural and Practical Preparations for Solar Eclipses. So just as a little bit of a background to this event, as you may already know, on October 14th of this year, a partial annular solar eclipse will be visible to millions across North, Central, and South America. Then on April 8th, 2024, we go even more extreme with a total solar eclipse that will traverse a large swath of North America. We're here to get ready to view these awe-inspiring events. We'll hear from our speakers, Murray and Chanel, on topics ranging from practical eclipse tips to the cultural interpretations of these amazing astronomical events through the ages, as we all prepare for these exciting sky spectacles. There will be lots of time for questions afterwards, and we'll chat and network throughout our time together, so please put on your best typing fingers. So let me just present here. All right, so before we begin, I would like to acknowledge and pay respect to the traditional land and Indigenous peoples on whose ancestral territory I am located today, as are many of you. I am specifically in Hamilton, Ontario, Canada. And as it goes, the city of Hamilton is situated upon the traditional territories of the Erie, Neutral, Huron-Wendat, Haudenosaunee, and Mississaugas. This land is covered by the Dish with One Spoon Wampum Belt Covenant, which was an agreement between the Haudenosaunee and Anishinaabe to share and care for the resources around the Great Lakes. We further acknowledge that this land is covered by the Between the Great Lakes Purchase, 1792, between the Crown and the Mississaugas of the Credit First Nation. Today, the city of Hamilton is home to many Indigenous peoples from across Turtle Island, and we recognize that we must do more to learn about the rich history of this land so that we can better understand our roles as residents, neighbors, partners, and caretakers. And many of you are joining from different parts of Canada, and some may also be joining from other countries potentially. And you may also wish to familiarize yourself with the histories and stories of the land and Indigenous peoples located on the land on which you live. So, for today's talk, I'd like to start out by telling you about Space Place Planetarium Canada, also known simply as Space Place. So Space Place is a Canadian charity comprised of a multidisciplinary group of professionals determined to bring an iconic physical public planetarium to Toronto. And we're currently supporting a vibrant virtual planetarium for Canada and the world. Not everybody knows this, but up until 1995, Toronto did have a world-class public planetarium. Toronto is unfortunately now the largest international city without one, and it's a critical missing piece of Toronto's tourism and educational infrastructure, and we really want to bring the big planetarium experience back. So I would encourage all our participants today to get involved in Space Place, email us to inquire about our work, be a volunteer, or apply to be a member. We are engaged in advocacy and planning, recruitment, events, and fundraising. So if you're looking to get involved in any of these facets, there's an area for you, and we would absolutely love you to join our team. So let's get started. I'm Sky. I'll be your host for this event. And we have Julie Tomei and Kristen Vanstone producing behind the scenes, monitoring our comments and questions on YouTube, and making sure that our Zoom call runs smoothly. So thank you to Julie and Kristen. As we go along, feel free to drop your comments in the chat box. Just to get things started, please, if you wouldn't mind telling us where you're tuning in from tonight, and tell us all one thing you hope to gain by the end of this event. So feel free to post that in the chat, and I'll be monitoring that for a couple of minutes, see if anybody says something. All right. Well, I am coming from personally from Hamilton, as I said. I know we have some people from Toronto here. Okay, cool. So that's very exciting. So for me personally, I still remember my first time viewing a solar eclipse in Ontario on August 21st, 2017. And this solar eclipse was a total solar eclipse. And while Stratford, Ontario was not in the path of totality, I experienced a partial solar eclipse where a portion of the sun was obscured by the moon. And the path of totality for this eclipse did pass through parts of the United States. And that was one of the many moments that built up my passion for space that brought me to where I am today, a fourth-year engineering student at McMaster University, a proud space nerd and fan of all things space, worked at MDA for these past 16 months until this past August. So that was a very important moment watching that eclipse. Has anybody here ever seen an eclipse or had any moments that shaped your interest in space? Feel free to share in the chat. Okay. Looks like you are all right. Let's see. All right. I'm going to share my screen again here. All right. So, a little bit more about Space Place. So just to tell you a bit more about our community, Space Place is a Canadian charity made up of a multidisciplinary group of enthusiastic professionals. And again, we're determined to bring an iconic 21st century public planetarium back to Toronto. And our mission reflects 4 key points: to serve the local community, educational and tourism needs, to promote awareness of Canadian space and space-related STEAM successes and opportunities, to promote online curriculum-based STEAM program opportunities and activities for underserved communities, and spotlight educational prerequisites for employment prospects in space and on Earth in various occupations in all its programming. One more thing here. We wanted to thank our amazing sponsors for helping us with this event. Space Place Canada has more than 10,000 supporters worldwide, mainly through social media and an active events program. And we're able to host amazing events like these greatly due to our sponsors. And so I'd like to kick things off by thanking our Jupiter sponsors, which are MDA, as well as Larson and Tubro Technology Services. And we would like to share a brief message from MDA. So we're going to play a quick video on that. I'm going to stop sharing my screen here. Awesome stuff. So thanks, MDA, and all of our other awesome sponsors. We also have Pratt & Whitney, which is a Mars level sponsor, as well as 2 Mercury level sponsors, which are Global Public Affairs and Stradia. Thanks again to all our sponsors for your continued support of Space Place Canada. So, and please email us at info@spaceplacecanada.ca if you'd like to apply to be a member or to volunteer with us. Now, without further ado, let's get into our speakers. So, first off, Murray Poulsen is a rocket and gas turbine propulsion professional with broad involvement in the industry. He is the founder and president of Launch Canada, an organization founded to support and advance experimental rocketry in Canada. He talks about discovering and falling in love with solar eclipses in the 90s, with his first solar eclipse in 1998 in Aruba, and his subsequent passion for finding the next one. 12 eclipses later, he has traveled around the world to see the ever-fascinating majesty of a total solar eclipse. Here we also have Chanel Virani, an award-winning astronomer, science educator, and creator of Our Island Universe, a weekly online podcast and science education platform promoting the public understanding of science, and co-author of Daughter of the Stars, a coffee table astrophotography photo book about light pollution and what we lose when we lose the night. From his 5+ years at the Harvard-Smithsonian Center for Astrophysics as part of the science team of the Chandra X-ray Observatory, to his graduate work at Yale University, studying supermassive black holes, Chanel has definitely had his eyes continually focused upwards. Chanel is now a member of the Astronomical Society of the Pacific's Eclipse Ambassador team, raising awareness and preparing local community astronomy enthusiasts to share the wonder of the upcoming solar eclipses that will crisscross the United States. Just to let you know, we will have question time after they speak, so keep your great questions stored, save it all for them after the talk so they can give the questions their full attention and they won't be missed in the chat box. So now take it away, Murray and Chanel.
Well, I will share my screen here and make sure that you're getting it. And it looks like it's live. Good. So, eclipse chasing, it's the chasers hunting for the greatest show on Earth. And I'll also tell people, come on over to the dark side, because it's something else. Let's see. We'll start off with a little bit of terminology. I'm going to be saying C1, C2, C3. C4 is not explosive. These are actual special events. And so C1 is when the moon first makes contact with the sun. C2 is when the moon is almost completely covers the sun and the last rays of the sun disappear. C3 is after totality is just over, and C4 is when the moon is exiting the sun and the last little glimpse of the moon trails off the sun. So that's a terminology that I'll be using that probably would be kind of opaque to some people. Well, this is the next decade of solar eclipses. And if we take a good look at this chart, you can see that there's ones that are all over the world. It's really cool. We'll concentrate tonight on just 2 of those eclipses. And those 2 eclipses are over North America. And the first one, as Sky mentioned, is an annular solar eclipse. Annular means that the moon inscribes the sun and we never lose sight of the sun during an annular solar eclipse. It will sweep down from the Pacific Ocean just below Alaska, across Oregon, down through Texas, Yucatan Peninsula, and then out across Brazil. About just short of 6 months later, we will get a total solar eclipse that will sweep up from the South Pacific across Mexico Texas, where it actually crosses the annular path, and then up through the Great Lakes region and off through Newfoundland into the North Atlantic. So we've got these two wonderful eclipses coming up. And so the first one is annular solar, which occurs on October 14th. It's only 11 days away, just to make that point. So this is really close by. And what you will see during an annular solar eclipse is you'll see a little bite of the moon taking out of the sun. It will grow bigger and bigger and bigger until, if you're on that path where annularity will occur, you'll actually see something that looks like the bottom image of the moon inscribed in the area of the sun. And then after it's declining, you will see the reverse process take place. You at no time will be able to look at the sun without eclipse glasses. So the eclipse glasses, solar filter of some sort, is essential. You have to have this. Otherwise, it can make you blind. And it's something that no astronomer wants to have to carry around a white cane. So it's a real serious impediment to your useful enjoyment of the sky. And strangely enough, an anagram of the October 14th, 2023 eclipse is the October 23rd, 2014 eclipse. And that's what the photograph down to the right is. If you're not traveling to see this next eclipse, the annular, it's a good time to try out your equipment and do a dry run. Get your solar filter together, binoculars, telescopes. Try it out, make sure everything works, because the April 8th eclipse is going to happen, and just like a steamroller, you can't stop it. It's going to come rolling by. Well, my first video here is the partial eclipse of 2014 on the 23rd of October, which, as I say, this is really cool. Now, I've got to see if I can find my movie. There's my movie. Okay, so everybody should be seeing a movie screen now showing a great big fat sun. And this is from that eclipse. So it's really clunky and doesn't have a nice frame rate, but it shows you what a partial eclipse looks like. And this is what anybody that stays in Canada for this annular solar eclipse will actually see when they come back to, let's see, oh dear, PowerPoint, there. So we should be back on the PowerPoint. Yes, we are. So if we look at what the annular solar is going to do for us, Vancouver, it's going to see a fairly deep partial eclipse. And as we move across the country, we get farther and farther from the eclipse path, and we will see the moon with lesser and lesser coverage of the sun until we get to Halifax. And it's just taking the tiniest bite out of the sun. So the moral of the story is, if you want to see this, you do need to get a little bit closer to it, but it is a good practice run. Now, to contrast that, next April 8th, we're going to have a wonderful total solar eclipse, and it sweeps across Mexico and the United States, coming up by Hamilton, Ontario, Toronto, and crossing back out through Newfoundland. And once again, you'll see a little bite taken out of the sun. It will get bigger and bigger and bigger. But at totality, you can take those glasses off. The sun is completely blocked by the moon, and you can see the corona and the sky unimpeded by eclipse glasses. It's absolutely spectacular. There is no photograph that does it justice. It's a beautiful, beautiful thing. And depending on where you are, if you're at Durango, Mexico, you'll see 4 minutes and 28 seconds worth of eclipse. It depends on your position entirely. And so what happens during totality? Well, I've got yet another video here, and I will grab the other video and put it up on the screen. And it would appear that there. Oops. I don't think I'm sharing yet. There. Yeah, okay, now it's good. Sorry, technical difficulties. So this is from Australia, and this is about a 2-minute long video, and it shows people in Exmouth, Australia, and it's already quite close to eclipse time. And you can see, watch how quickly it becomes dark. It's lit, and then all of a sudden it becomes really dark really, really fast. And there's a gentleman in the background that's announcing, don't take your camera filter off until I tell you, and things like that. And then all of a sudden, bang, it starts getting dark. You take off your filters from your camera, and then all of a sudden, the sun is just spectacular. The sky is dark. The halo of the corona around the sun is just incredible. And you don't need your eclipse glasses.
Oh wow, they've got this practice way above the sun.
Don't I sound erudite? And the chromosphere means the eclipse is almost over. And you can see the light just come right back up, and the shadows, all of a sudden, they're there.
We'll find out if it works. I don't even want to look at it. I don't want to spoil it.
So that shows you what you get for it. And so what do you see when this thing is actually going on? And turns out, let's see, this is what the chromosphere looks like. And this is about 45 frames of still images put together to show the Bailey's beads, the chromosphere, the corona popping up, and then the Bailey's beads coming back out at the top of the sun. Now, I took a second set of videos, and this is the inner shots showing the chromosphere of the sun. The chromosphere is the atmosphere of the sun, and it's only about 6,000 kilometers deep. And I will play that one more time. You'll see the Bailey's beads at the bottom disappear, and then the pink rime will wrap itself around the right-hand side or left-hand edge of the sun. And then finally, the Bailey's beads will pop out again at the top of the sun. This was incredibly beautiful at the site where we were observing it. I will come back to the PowerPoint slideshow and get through these two. So what do you need to go see one of these solar eclipses? Well, the first thing you need is you need to know where to go. The path of the shadow is the king. If you're 1 kilometer outside of the path of totality, you have to keep your eclipse shades on. You can't look at the sun without something to protect your eyes from that searing brightness of the sun. You also need mobility because the weather sometimes has other plans and you need to negotiate your way around it. So you might have to drive hundreds of kilometers, and we have in our experience. You also need a solar filter, at least for your eyes, but you can make one or buy ones for your binocular camera, telescope, and you need a safe place to observe the eclipse. Like you don't want to pull over on the edge of the road and have the chance of some distracted driver run into you on the edge of the road. You need to be off the road where you've got a safe place to sit and watch the eclipse. And the last but not least thing is the roads may get really, really busy with people rushing down to see it. It was crazy in Idaho after the eclipse. The traffic jam that left the area of totality took about 6 hours to clear out. So we could see crazy things like that this time as well. The drift of traffic into the eclipse path wasn't that bad, but the drift coming back out was just awful. So be careful and give yourself lots of time. Solar filters, okay. You're going to need these things. And there's a couple addresses that I put in the handout. There's a number of different companies. You can buy glass solar filters, black mylar or silver mylar solar filters. They all work. And you don't need glass over mylar. They both seem to be optically fairly good. These are just 2 of the many companies that sell them. And there's a Canadian company among the group that I've provided in the handout. Some important websites. There's a gentleman by the name of Fred Espenak. He worked with NASA, produced eclipse predictions, and another gentleman, Xavier Juber, who produces eclipse maps. Their Google interactive maps are really cool. And a man by the name of Jay Anderson, also Canadian, who produces eclipse weather reports. And so I'll go through these things. Here's a Fred Espenak's site. And you'll notice he's got lunar eclipses and solar eclipses. And if you click on the solar eclipse, bingo, it will pop up and tell you some important details about that eclipse, the date, the time, and the duration of the eclipse down in the corner here. It says 4 minutes, 28 seconds. And from Durango, Mexico, it will be at an altitude of 70 degrees. So cool stuff. And then if we go to Jay Anderson's site called Eclipsophile, he does climatology and he looks at the weather, and he's got about 40 years of satellite data that he can rely on. And he looks at the average cloudiness at different places across North America. And you want to know these kind of things because you don't want to go to the cloudiest place on Earth to watch a solar eclipse. You want to go to the best place to improve your odds. It always doesn't work, but it helps. For those of you that are in Toronto, well, you don't get a total solar eclipse. You get a deep, deep, deep partial. You will be one of the people with still squinting through your solar glasses, while the people in Hamilton, only 3/4 of an hour drive away, will get 2 full minutes of totality. If you continue driving and go a little farther, Niagara Falls gets 3 minutes and 30 seconds worth of totality. And if you look at this map, you can see that the area of Toronto, Hamilton, and Niagara Falls, it's actually in the sort of yellowy region, which is, there's a 60% chance that there might be clouds at the time of the eclipse. Whereas if you go down to Texas and you see the big star, that's where we're going to be. We're renting a campground in just west of San Antonio, and the chances there are probably closer to 45% chance that there might be some cloud on eclipse day. So it's a great improvement. If you go to Durango, Mexico, it's down in the 10% chance, and Mazatlan looks really, really good as well. So lots of interesting possibilities. And there's all kinds of statistics and maps on Jay Anderson's site. So do give it a look. It's also listed in the handout. So now you've figured out what a bunch of different things can be. You can come up with a plan B in case the weather goes bad. Check the weather the night beforehand, or watch it during the week beforehand. Mobility is really, really important. And the important thing also is know where the path is and what roads will take you east, west, to get you into clearer skies. That's where Xavier Juber's stuff is really good. And advice for those that are going for their first trip, enjoy the eclipse. It's real easy to get hung up with your camera and photography, but an eclipse goes by really quickly. If you've got some portion of 3 or 4 minutes worth of an eclipse, you don't want to discover that you're looking at the back of the camera when the curtain fall of the Bailey's beads comes popping out, and you just missed visually looking at it. I've seen people who've done that. So for your first eclipse, watch it. It's a wonderful spectacle, and you do not want to miss it. An interesting thing to have is a pair of binoculars. You can hang them around your neck. You know where they are, and you will be able to look at the sun. I used to give myself 1/3 of an eclipse because I'm an ardent photographer. Middle third of an eclipse, I would sit with the binoculars and enjoy, at least 1/3 of the eclipse through my binoculars, looking at the sun and looking around me, and then I would go back to my photography. So the good thing to do is have a look through your binoculars. Look around, you will see a 360-degree sunrise sunset, because you're in a dark circular zone, and way out on the edge of it, there is sunshine. And so you get those wonderful sunrise sunset colors all along the horizon. It's really, really cool. And it's all the way around you, all 360 degrees. Also, Venus will be about 15 degrees below and to the east of the sun. So give that a look. Or south of the sun. I keep getting mixed up looking at the geometry of things. So setups for photography. You can put a camera on a tripod and take pictures away. This is Joanne and her setup. She's got a solar filter on a 200mm Canon camera lens, and she has no motorized drive, but lots of good photographs from the Exmouth eclipse. The gentleman on the right had a camera on a motorized LTAS mount. This is a cute little item. It has 4 AA batteries, and it tracks the sun while you're sitting there. It's really, really cool. And all because it's not an equatorial mount, it doesn't need a counterweight. It's a very, very simple use, and extremely light for the suitcase and packing up. This is my equipment. I have 2 versions that I use. In the left-hand side, I've got a 400mm Canon lens with a 1.4 converter on it, and you'll notice there's this little tiny equatorial mount. It's a little traveling mount that Takahashi makes, and it's wonderful. If you look at it, you'll notice that it's really weird. It's polar aligned horizontal. This is in Indonesia. It's really hard polar aligning when Polaris is on the horizon. Down below me, you will notice on the ground, I've got a little red flashlight. It's really critical to have a flashlight, because during an eclipse, it gets so dark that if you drop something on the ground, or if you want to change the settings on your camera, you can't see it to be able to do anything. it's dark. The longer the eclipse, the darker it gets, because the only light you're getting is from the horizon, which is that muted sunrise sunset glow. It's quite amazing. On the right-hand side is the setup I took to Exmouth, and it's a little Williams Optics 71 millimeter scope, and it worked quite well. And same little Takahashi mount. It's little equatorial. The nice thing about it is it keeps the sun in the center of my field of view, and I don't have to worry about tracking the sun during the full term of the solar eclipse. And that I find to be quite handy. You'll notice on this one that I've got one of these little red BB gun sights, and if you put a little piece of cardboard in the front with a little hole in it, you'll get a projection of the sun on a piece of cardboard that you stick with double-sided tape on the back of it. And this lets you easily align if you get bump the telescope and you need to find your way back to the sun. It's amazing how hard it is to find the sun through a telescope if you don't have a finder. Try it. It's really quite amazing. Next thing on my list is binoculars. These are wonderful things to look at the sun. Just about any binocular will do. You don't need a great big binocular. Here's a 30 millimeter binocular on the left, 42 on the right, or on backwards. I'm dyslexic. Canon binocular is a 42 mil, and the Zeiss binocular is a 30 mil. All you have to do is get some solar filters for them, and they'll work marvelously for your eclipse. On the right-hand side of the screen, there's the Lunt 8x32 sun oculars. Now, these are peculiar. They've actually got solar filters built right into them. The problem with them is that you can't take those built-in filters off. So I'm not really sure. They look like a good idea, and they're not cheap, but they might be of interest to you, because at totality you can put them down. You don't need them during totality. And if you're going to go crazy, you can get into the big aperture binoculars, and on the left is a gentleman with a pair of 80 millimeter Zeiss binoculars with solar filters, and on the right side of the screen is a pair of 20 by 100 binoculars with full aperture solar filters. And so you can bring whatever your heart desires to the eclipse, as long as it can get through the luggage in the airports or be put in the back of your car. It's great. Binoculars, well, if your filters aren't really secure that you put on it, you can use painter's tape to secure the filters. And this might mean that you can buy a pair of sacrificial 3D or solar glasses, cut them up, and then tape the filters onto the front of the binoculars so that you can actually look at the sun with your binoculars during the partial phases. And then when it comes time for totality, you can just peel the tape off and look at the sun with your binoculars, and you can put it back on afterwards. Or you can get you can buy filters, or you can get a friend to 3D print a filter mount for you and make your own with some solar film. And I've got some suppliers of solar film in the handout listed. So cool stuff. Okay, so how much does the sun move? Now, do you really need an equatorial mount? Well, the Earth rotates once in 24 hours. Sun is half a degree in diameter. If you do the math, it means that the sun moves about 1 degree every 4 minutes if it's on the equatorial plane, or it moves its own diameter in 2 minutes. So if you're shooting a 4 minute long eclipse, that means the sun's going to move 2¼ degrees. So if your lens will accommodate it, well, you don't really have to worry about moving or tracking the sun. It is kind of nice to keep it together if you want to do videos by compiling a set of your images together. So that's the one thing for it. So we know how far the sun's going to move while you're watching the eclipse and photographing it if you're photographing it. How long an exposure can you do without streaking your image, without having an equatorial mount? Well, the general rule of thumb that I've come up with is that the maximum duration of your exposure to not have a trailed image
Oh, looks like we may have lost Murray for a second. We'll just wait for him for a few seconds. The joys of online calls. All right. Let's just wait for a minute or two, see if he can connect. And then if he can't, then we will have Chanel come up and do his presentation, and then Murray can leave off, can pick up where we left off. So we'll just wait until just for one more minute, and if he does not come back, we will start with Chanel's presentation. Actually, I think we should be good to go now. Why don't we just start with Chanel's presentation, and then we will catch Murray a little bit later.
Okay, let me share my screen. So first, let me say what an honor and a privilege it is to be invited to share my thoughts about solar eclipses. But I wanted to start with, I was a young high school student between 1988 and 1992 in Toronto at Mark Renault Collegiate Institute in East York. Well, I guess it's not East York now, it's just all Toronto. But the McLaughlin Planetarium nourished and cultivated a sense of wonder and awe. And as a planetarium director now at two different institutions in the United States, to me, it's a travesty that one of the largest cities in North America does not have a public planetarium. There is no more powerful driver in motivating and inspiring the engineers, scientists, technologists of tomorrow than a multimedia immersive planetarium. So I'm ecstatic to be here and to be associated with Space Place and bringing back a public planetarium to Toronto. It played a pivotal role in my career arc. So tonight, I'd like to share with you some stories and a little bit of the physics of eclipses. We saw through Murray's presentation some of the beautiful images that can be seen when you're looking at a total solar eclipse. This background is a Google map with, in this case, the total solar eclipse of April 8, 2024. And for those of you planning to drive or to go to various vicinities to get into that path of totality, the ASP, the Astronomical Society of the Pacific, that's where I currently work, has a Google map where you can see the paths and you can navigate through. These are just still images that I've taken for the presentation. So as we've heard a couple of times now, we're pretty fortunate. We had a total solar eclipse, of course, on August 21, 2017. some 6 years ago. And in the next few months, we're going to have two. Of course, there's one in 11 days, October 14th. That's an annular solar eclipse. And of course, the April 8 one is the one that's very exciting because it's a total. And of course, there's a large population of people, large population of Canadians that will get to witness it for the first time. So this is looking at the path of totality. This is the band where if you're in this band, of course, you will see a total solar eclipse. This blue line is where you get the maximum duration, as large it is. And this to me is somewhat of a cosmic joke. Canada's largest, most populous city is just to the west of this band. And so, of course, as Murray was saying, if you're in this vicinity, if you're in this region, you're going to see a partial solar eclipse, not a total solar eclipse. You don't have to go too far, however, to get into that band. Of course, you go to the Niagara Peninsula, you will have a great opportunity. Rochester, New York, if you want to cross the border and go somewhere reasonably close, they've ordered more than 100,000 solar glasses, and they're planning a big party. And you can see they're not too far away from the maximum peak, but you'll still have a great show. To me, this has always been burgeoning some entrepreneur to charter a boat and to take some Torontonians and wait for it, go into the path and make a boatload of money, be able to get to see that path. And maybe that'll happen. Maybe there are issues that can happen, but if you're in Toronto proper, you have to move, you have to travel if you want to experience totality. Now, what do you see? What can you see in these different paths? Of course, this is now those two maths, and depending on where you are, if you're in the path of totality for the April 8, 2024 event, you get a beautiful view like this, and you saw some of the images, beautiful images that Murray has taken. There's a whole bunch of really cool physics and exciting physics that happen. For one, this corona is a diffuse multi-million degree gas, tenuous gas that you can only see during totality. And if you stop to think about it for a second, you know, this chromosphere, this outer atmosphere of the sun is about 6,000 degrees. This tenuous gas is many times hotter, millions of degrees. And so one, of course, for a lot of solar astronomers and solar physicists, trying to understand the physics of what's driving the energetics to heat this diffuse gas has been a long outstanding question. We have ideas, and of course, we have satellites that are now going towards the sun to probe this. If you're want to look at the annular, which is the one that's in 11 days, next Saturday, you're going to get this annular, and even that is beautiful. Now, of course, as Murray said, the one key difference between an annular and a total is that during an annular eclipse, you need solar glasses at all times. That can't be stressed enough. Your eyes are very delicate and they are one of a kind optical instrument. You cannot afford to do damage. So at no point should you take your solar glasses off during an annular. In a total solar eclipse, when you've got that those few minutes of totality, as you see here, of course, you can take your glasses off and take in that view. If you're not in this path of the annular in October, next Saturday, or if you're not in this path of totality next April, what are you going to see? Well, you're going to see that partial eclipse. And even with, again, you need glasses to see it. And when you do, it's kind of like Pac-Man, right? A little bit of the sun has been taken out by the moon. So let's explore some of the physics about what's going on to get it. Eclipses, to me, are an incredible social event. And what has happened, of course, in the last few hundred years is that our understanding of the natural world, of course, has increased exponentially. And unlike our ancestors, we know what is going on and we can explain it. For our ancestors, right, there was a lot of mysticism and a lot of unknowns. This daily cycle of day and night, we take for granted that the sun will come up tomorrow. For many cultures, it was not something you took for granted. You didn't know if the sun was coming up, and there were various rituals and and religious connotations that came with it, so that the sun would come back tomorrow. We know what goes on, and this cycle of day and night has to do with the Earth rotating on its axis. So for a lunar eclipse, which is another kind of eclipse, but we haven't talked about it, the geometry is such that you've got the sun, the Earth, and the moon in a line. The solar eclipse, and whether it's an annular or total, you have a geometry that looks something like this, where you have the sun, the moon, and then the Earth. And then, of course, this popular meme says that if you get this kind of geometry, that's an apocalypse. This, of course, is a joke because the moon orbits the Earth, and to get the moon on the other side of the sun, something catastrophic must have occurred for that to happen. All right, so this, of course, is fictitious. It's just a joke. What is going on? I need to move my Zoom camera so I can see it. This is just, a kind of Astro 101 ray trace. You can do this with kids too. You draw the sun, you draw the Earth, you draw the moon, and then you ask, where's the shadow? And you can take a solar ray from the top of the sun, hitting the top of the Earth, and you extend it. A solar ray from the top of the sun going to the bottom of the Earth, and you can extend it. And then you do the same thing from the bottom. And what you do as a result then is you can see this darker portion is where you've got the Earth's shadow falling into space, where when the moon, as the moon moves through in its orbit and enters the shadow, you of course get the total lunar eclipse. The penumbra is the outermost part of the shadow, where there's still some sunlight. And in fact, to the eye, you can't tell a difference between the penumbra and this part. This is very bright still, and all the action for a total lunar eclipse. And I'll show you a photo, because I think these are just as exciting for different reasons, the social aspect and the storytelling aspect of what our ancestors saw and thought when they saw a total solar eclipse in a moment. There we go. For a solar eclipse, of course, the moon is in between the Earth and the sun, but you can do the same ray trace. And what you notice, of course, is the shadow cast by the moon, because it's much smaller. It's roughly a quarter the size of the Earth. It casts a much smaller region of a shadow on the Earth. The question you might ask, however, well, what's the difference between an annular and a total solar eclipse? Well, as you know, of course, the orbit of the moon around the Earth is not a circle, it's an ellipse, which means it has the distance from the Earth is changing. And so what's going to happen on the next new moon, which is next Saturday, October 14, the moon is just going to be slightly further away from the Earth than it would be in this case. And that means this shadow is somewhere out here, somewhere above the Earth's surface. So we don't get to see a total solar eclipse. Earthlings looking back out at the sun with their solar glasses on will see that annular, where you'll see the sun in a ring around the moon. Again, beautiful, makes for fantastic imagery. But however, again, I remind you, you need glasses to observe it. Now, as Murray was saying, for the April 8, 2024 total solar eclipse, these times that we talk about, the maximum duration is 4 minutes in Durango, but here for most paths, you're going to get 3 minutes, 2 minutes, depending on where it is. Now, I compared that because you can see it's a small shadow. And so, of course, as these motions of the moon and the Earth in its orbit, of course, will change where on the Earth the shadow is intersecting. As opposed to a lunar eclipse, this band of shadow is much wider. And of course, it's why lunar eclipses last for a couple of hours, not a couple of minutes, like a solar eclipse. Now, just to give you a perspective, to give you some reference, so we'll get about 3.5 minutes, 4 minutes, and if you're on the Niagara Peninsula and you're watching it from Southern Ontario, the one in August of 2017, August 21st, 2017, that maximum was just about 2 minutes and 40 seconds. And of course, one question you might have is, why are these times different, and what governs those? It has to do with the various celestial mechanics of Kepler's laws as we would apply to orbits, of the moon around the Earth, and of course the Earth going around the sun. But for us, about 4 minutes in the Niagara Peninsula. Now, for a total solar eclipse, it's the moon blocking the sun, and this is one of these tremendous cosmic coincidences, because of course, if the moon was any more smaller, if the moon was further distance, we don't get that block. We don't get the moon blocking the sun completely. And of course, that means we don't get to see a total solar eclipse. So we're lucky that we've got the geometry just right and the sizes and the apparent sizes just right that we get to see a total solar eclipse on April. One of the interesting consequences, as you might know, the moon is actually moving away very slowly, away from the Earth at a rate of about 2 inches per year. That's about 5 centimeters, the rate at which your hair grows. And that means in about 600 million years, the moon will have moved enough further away that we will no longer have total solar eclipses. In fact, it's estimated that 90% of all the total solar eclipses the Earth will have seen have already occurred. The Earth is 4.5 billion years old. 600 million years doesn't sound, sounds a long time, but compared to the age of the Earth, it's a very small fraction. So because of this cosmic dance, we're lucky to live at a time where we get to see it. To our successors, whatever form they might be in 600 million years, total solar eclipses will no longer be the norm. They'll see angular. So what happens? So this is a fantastic imagery taken from space, where you get to see the shadow cast on the Earth, and of course, moving across, and the Earth rotating. So this was taken from the Earth Observatory and NASA Observatory. And of course, you can see Australia down here, and you can see the shadow crossing over the Pacific. And so this is what you're seeing in those images that Murray showed. What is the physics going on? It's the shadow cast by the moon on the Earth. And in this vicinity where you see this dark patch, those are places where if you're looking out into the sky, you're seeing the moon blocking the sun. Now, as I said, one of the really cool things to me about solar eclipses is the breathtaking beauty, certainly, of witnessing an event like that. For a total solar eclipse, as you saw in one of Murray's vignettes, right, the sky gets dark. The temperature drops by some estimates by about 10 degrees. In fact, one of the cool experiment, if you have young kids and you're going to do this, is actually get a digital thermometer, and do it. Have a thermometer set up while the sun is fully out, get a temperature, and then pay attention and maybe take some readings, and you can plot. All kinds of really cool science you can do during that. Of course, for nocturnal species that are asleep during the day, they get fooled. They think darkness has arrived. They wake up and they go on their merry way, thinking it's active time for them, only to realize that 2.5 minutes, 3 minutes, 4.5 minutes, whatever the duration may be, the sun will return. I want to show you a brief clip from people experiencing totality, because I think this is really the most exciting thing. It's sharing the experience with other people and witnessing something fantastic. This is from National Public Radio, NPR. The full video is about 7.5 minutes. I'm only going to show you the last 3 minutes. So let me get this going, and I'm going to advance it to where I want to show it. So.
Oh my God! There it is! Incredible! Oh my God!
Experiencing this together.
That's an impressive sight.
Here it comes.
Look at the street lights coming on.
For a little bit.
Stop it. You see him? The street lights are on. Oh, look, I can just see it. It's going. It's almost.
It's almost there!
Oh, wow. Look at that. Whoa. Whoa. I never thought I'd see this. Oh, my goodness.
my
Whoa! Oh, God, take a photo.
Damn.
Holy.
This is so crazy.
Wow. Look at how dark it is out here.
Oh, look at the skyline. It looks like nighttime.
It was amazing. Like, you stop.
When that diamond ring came out.
It kind of felt like love.
I heard little crickets come out chirping and all that because it got dark, and I don't know, and I felt the temperatures rise.
Celestial things are just beyond comprehension. And when you see one and it's really there, and we're all here,
no matter who you were,
everybody's
what your
different.
beliefs were, what your morals were.
Joy
So,
Sort of let you see where we sit in the cosmos.
you know, because we all are experiencing life the same way. So,
what color, what political, anything. Everybody's like,
I think it's something we all really need right now. It's just to feel connected in a way.
There was such a camaraderie and friendliness, and we were literally touching and hugging each other.
I bet the whole world was looking up. I bet the whole world was looking up.
I love you.
I feel that I'm going to go on YouTube, aren't I?
You know, I get goosebumps every time I see that, and when I teach and I share that clip too. You know, it's one of these unfortunate consequences of I guess our modern lifestyle. We're so divorced, so separated from the natural world nowadays. You know, in GTA, you look up on a clear night, maybe you see 5 stars, 10 stars if you're somewhere dark. You know, we just don't experience the night the way that our ancestors did on a regular basis and took for granted. On a moonless night, the sky is kind of what you would see, what you see behind me, littered with stars and the Milky Way blazing overhead, bright enough to cast shadows, bright enough to read a book by on a moonless night. You know, we just don't get these, just don't get those experiences anymore. And, you know, by some estimates, some 80% of the world's population now live in areas where they don't see the Milky Way. And so I think that's what you see or witnessing when you see that video like that. It's connecting with something in the natural world. And eclipses are rare, yes, but it's connecting with something in the natural world that we've kind of forgotten. And so if you do get the opportunity to travel for next Saturday, for the annular, or on April 8th to see total, do it, because it's one of those things that will last with you for a lifetime. Now, coming back to the kind of the physics of these eclipses, from those pictures that I just shared with you of the geometry of the Earth, Moon, and Sun, one thing you might ask, well, how come it is so rare? If you need the Moon in between the Sun and the Earth to see a total solar eclipse, or you need the Earth in between the Sun and the Moon to see a lunar eclipse, well, you know, we have a full moon every 2 weeks from a new moon. We have let me say that again. We have the moon going through its phases every 28 days or so. It's 2 weeks from a new moon to a full moon, and then a full moon to a new moon, another 2 weeks. Of course, to our ancestors, that's a pattern they observed. And of course, that's where the word month comes from. The next time you say it, think month, right? To our eye, that cycle repeats about every 30 days. And that's where that time scale, it's why a month is 30 days. You might have wondered, why is it not 10? Why is it not 5? Why 30? It's because our ancestors in almost every culture was involved in looking and interpreting and coming up with these stories, and that time scale of the lunar phases repeats every 30 days. So how come we don't see a lunar eclipse and a total solar eclipse every 2 weeks? And that's one of the more fascinating things, is that the the orbit of the moon around the Earth, and this is somewhat of a complicated picture, but I'll try and walk you through it, is tilted by about 5 degrees, roughly 5 degrees, with respect to the plane that defines Earth's orbit around the sun. And what that means then is that sometimes the moon is just a little bit below this geometry of the Earth and the sun, and the moon therefore does not block the sun. Sometimes it's a little bit high and it doesn't block the sun, and so we don't see a solar eclipse or a lunar eclipse. There are only 2 positions, and these are called the nodal points. So if you take an Astro 101, you talk about the ascending and descending nodes of these eclipses, and about these orbits where you get the geometry that makes it so that you can see these eclipses. And to me, what is fascinating is, here we have a physical explanation, a scientific explanation of what causes these total and lunar eclipses. But for many cultures, and it's clear that at least for the ancient Mesopotamians, this pattern of predicting eclipses was known to them. It's called the Saros cycle. And they could predict. They didn't understand, and they didn't have the physics to explain what was going on. There was still a lot of magic, I suppose, and cultural response. And I'll share some of the stories with how they interpreted it in a moment. But they had the ability to predict. They had the ability to predict of when eclipses would occur, because if you observe long enough and you collect data long enough, you find these patterns. So the solar versus lunar, you've seen lots of pictures from Murray. Of course, you see that again, the beautiful corona during its totality. To me, and as a kid growing up in Toronto, going to high school in Toronto, there were several opportunities to see lunar eclipses. And that blood red, I have distinct memories of seeing a lunar eclipse, and it lasts for a long time, so you can participate in. And there are lots of stories from many cultures that saw something like you see in this photo, then of course had to interpret what you see. The physics, of course, of why you see this blood red, of course, the Earth has an atmosphere, and that sunlight is refracted through the atmosphere, and then, of course, directed towards the moon, and you see that reddish light. If you remember your middle school science, blue bends best, right? That blue light is scattered in all those different directions. It's that same blue light bends best, that we have a beautiful blue skies during a cloudless day. Well, that red light doesn't bend as well, doesn't scatter as well. And so that red light, the longer wavelength light from sunlight, you can see reflected off the moon, giving you that reddish glow. A romantic way of interpreting that is you're seeing either sunrise or sunset everywhere on the Earth at the same time, reflected on the moon in that reddish glow, which I think is another cool way of visualizing it. So some of these stories, and I want to be careful of the time because I know we want to go back to Murray, but I'm just going to share a few. In many cultures throughout our history, Homo sapiens, our species, is some 250,000 years old. But it's clear that many cultures, and they built monuments to tell us that they were observing, whether it's Stonehenge in England, Newgrange in Ireland, Chichen Itza in Mexico, Angkor Wat in Cambodia, or places in South America. They build these monuments to pay attention to these patterns. And so for many cultures, the sun was a god that they worshipped. Amun-Ra to the Egyptians, Helios to the Greeks, and likewise for some of the Baltic cultures. And of course, you can understand why. Again, for us, we know this daily cycle of day and night is a consequence of the Earth rotating, spinning on its axis. But again, for very early cultures, this was not clear, and tomorrow was never guaranteed. Sunlight was never guaranteed. And so you can imagine a deity or a god or a goddess being created to explain what they saw. One of my favorite stories is a Hindu cultural myth. And it's also depicted in Angkor Wat, the story in Cambodia, on some of the bas relief paintings, if you had a chance to go and to see the Hindu temple there. But the story is that Rahu is immortal, and he's looking for this elixir of immortality. The story goes is that let me get this right, is that the demon Rahu is trying to find this elixir, and the twin deities of the sun and the moon find out, learn about what he's looking for, and decapitate Rahu. And so as he swallows the moon, it turns red because the moon comes out the other side. And so because he's been decapitated, of course, it's covered in as gore and red. And that was one way of doing it, and hence the blood red. Having consumed the elixir, Rahu's head, however, remains immortal. So he spends eternity chasing the sun, chasing the moon. And when he catches them, he devours them. And hence, that's how they explain these eclipses. The interesting thing to me is that, of course, is our scientific understanding of what eclipses and how they happen. The Rahu and Ketu then become associated with the nodes. So this branch of looking at astronomy and that intersection with culture and society used to be called archaeoastronomy. It's now called cultural astronomy. Some of the stories that we've created to explain, and it's a fascinating idea. I'll share a couple other ones with you. For early Inuit culture, an eclipse meant that the sun and moon had become temporarily diseased. And so in response, they cover everything of importance, themselves included, because they didn't want to be infected by the diseased rays of the sun. They chose not to observe, which to me is incredible. For some indigenous populations of the Great Lakes, the onset of totality represent an extinguished sun. So to prevent permanent darkness, they fired flaming arrows at the darkened sun in an attempt to rekindle it, to restart whatever fire the sun was, to see it come back. In history, there's the solar eclipse of 528 BC, which occurred during the middle of a battle between two warring factions, two warring groups in modern day Turkey. And this eclipse ended the spot. One of the things that we quickly realize is, of course, totality and solar eclipses in particular. We think of them today as fascinating science events to witness, but they often were harbingers of doom. And in fact, for the ancient Mesopotamians, yes, they could predict it, but they saw these eclipses occurred at a very sensitive time because they could predict the eclipses, and because they were worried about the lives of their king and whatever chaos may ensue. They would place a surrogate king in place of the real king, and the real king would go into hiding and wait for the eclipse to end. And then, of course, once it did, because it always did, the surrogate king would conveniently disappear. The disappears in quotes, you know what happened. And the old king would resume their throne. I don't know how you get that job or how you get selected, but that's not a job I would want. This, to me, is probably one of my most fascinating, and I just love this image. So, of course, this is a lunar eclipse, and it's because of everything you see here in one mosaic. Of course, you see the moon moving through the Earth's shadow, right? And you see the blood red, and then escaping from the shadow. There's so much going on. You see the blood red, of course, from the total lunar eclipse, but you also see the Earth's shadow in projection. And for the ancient Greeks, some 2,000 years ago, Murray was talking about those contact points. Aristarchus realized that if you can measure the length of these total lunar eclipses, that gives you information about the sizes and distances. So the ancient Greeks, some 2,000 years ago, not only did Eratosthenes, an ancient Greek some 2,300 years ago, figure out that the Earth is a sphere and figured out the radius or the diameter of the Earth to better than 10%, 2,300 years ago. They knew it was not flat. They could also do this kind of astronomy to get sizes and distances. And so this, to me, is incredible. So coming back to this event next Saturday, if you want to see the annular, you know where you need to go, or next April, if you want to see totality, you know where you need to go. But even if you don't go anywhere, again, you're going to see a partial eclipse if it's clear out where you are. And again, get those glasses. If you do go, again, please wear those glasses. But there are a lot of other things you can do. And if you have young kids at home, or even middle school kids, high school kids, there are a lot of really cool things you can do. One, of course, is you can wear your protection and take in the event, but you can also make pinhole projectors out of a cereal box, out of a shoe box. And I can send PDFs that the Space Place can post, and you can do this at home. It's a great way of taking in an eclipse and seeing how to do it safely. One of my favorite is just taking a colander, something you would use to rinse vegetables and fruits. You line it up with the sun, you can see the eclipses in projection on the ground. And I suspect for many cultures, not having solar eclipse glasses, this is one way they may have noticed that there was something going on. Through the leaves, that kind of serves as a pinhole projection. They would see this way. Or transit of Venus, for example, where rather than the moon crossing the sun, you would have a small dot of Venus crossing the sun. And so seeing this in kind of projection would have been a way that some early cultures would have been able to see those kinds of events. This is just a regular cereal box where they've put in a hole. You can see this gentleman is looking towards the left. There's a little pinhole here, covered with aluminum foil, and there's a reflective coating there. He's looking at the other on the right-hand side and seeing the projection at the bottom. So, these are great ways of taking in an eclipse, of watching it safely, and great activities to do with kids. If you're not traveling next Saturday, or if you are clouded and you want to see what it looks like, as part of my regular day job with the Astronomical Society of the Pacific, I'm actually headed to Ely, Nevada. It's about 4 hours north of Las Vegas, and we're expecting some 2,000 to 5,000 people next Saturday to descend in Ely, Nevada, to watch this annular solar eclipse. We're working, the ASP, the Astronomical Society of the Pacific, is working in collaboration with the Exploratory Museum in San Francisco, and this will be online via their webpage. And so you can see us and see the people that are taking in the eclipse. We'll have pictures, photos, and a live feed. So if you're clouded or you just want to watch it at home, join us and join me. I'll stop there. Sky, if Murray wanted to pick up, so I see he's back.
Yes. So, all right. Thank you so much, Chanel. That was an amazing talk, very interesting. I'm sure everybody found it super informative. So now we shall get back to Murray. He had a few technical issues, but he's back and ready to go. So we'll finish up his presentation, and then we'll have some time for questions at the end. We're already getting some questions, so that's awesome. All right, take it away, Murray.
Thank you. Okay. Let's see if you've got me. All right, you've got my screen now. Good. All right. Windows decided that it had to update my computer. So the joys of Windows. Anyway, back at the ranch, things we had left off talking about how long you could expose for, etc. This stuff will be in the handout. Things to bring to an eclipse. Well, number one, camera. Use your phone for video. And if you're going to use your phone for video, you need a tripod or something like that. For your camera, you're probably going to need a tripod, binoculars, and solar filters for those things. A chair is a wonderful thing to have. I actually took a chair to an atoll in the Pacific, South Pacific Ocean, to watch the sun be eaten by clouds just seconds before totality. So it was lovely to have a chair to sit down and cry in my beer. A Richfield telescope on a tripod is really handy for looking at a solar eclipse. And of course, if you want an equatorial to keep your camera driven, you can buy these little compact equatorials. Okay, let's go to the next one. Things to look for during a solar eclipse. Well, what's really cool about the sun, when the moon is covering it, you end up with something that almost looks like a slit. It's the narrow edge of the sun as it's almost at totality. And so it's asymmetrical. You've got a very sharp, narrow, bright object that's lighting up your universe. And because of that, the shadows going perpendicular to the narrow direction are really, really harsh. They're very, very narrow. So the lighting looks really, really weird. And in the opposite direction, along the axes of the crescent, you still get soft shadows like you get during the normal days. In the diagrams that Chanel was showing you, there's that penumbral area in the shadow of something that is lighting up the ground. So if you hold your hand out, your fingers aren't a harsh shadow on the ground. They're not an exact duplicate of your hand. There's a soft shadow around the harder inner shadow of your hand on the ground. Well, if you look at that during a solar eclipse, in one axis, the shadows will be soft, and in the other axes, they will be harsh. And the eye picks up on this, but you might not notice it. And so it's one of those things that would have put people on edge in ancient times, because you don't know why, but everything looks weird. But it looks the same as normal, but no, it looks weird. It's a really strange thing. I also noticed that the light near totality, it looks silvery. There's sort of a silver quality to it. It's really crazy. There are crescent images of the sun projected through pinhole cameras. And of course, you had a few shots of those through colanders and things like that. Also birds and animals preparing for night and acting afterwards like sunrise. You hear a cock crowing after sunrise if there are chickens around. The cooling down of the air over the event, it's quite fun. You see these people in shorts and a t-shirt, and all of a sudden see them wearing a towel or something over their shoulders to keep them warm about around the time of totality. It gets quite cool. If you look towards the west, you can see the shadow of the moon coming in if you're in a place that's high enough. It's really cool. We were on a butte in Idaho, and we could watch the actual shadow of the moon coming towards us. It looks like a darkness in the west. And that's actually the shadow of the moon approaching you at something like 3,000 kilometers an hour. It's really cool. Also, the 360-degree sunrise sunset. It is so amazing to see that. And definitely make sure that you at least turn around and see it. And also note how dark it really gets during an eclipse. Some people will actually wear an eye patch on their eye. They'll look like a pirate walking around so that they can take it off during totality, and they can see the full extent of the corona of the sun, because the corona extends way out. The only reason why you don't see all of it is that you haven't totally adjusted to the darkness. And then the shadow bands are phenomenon from that slit lamp kind of issue of the crescent sun, causing these dark moving bands. And what you need is a white sheet, and you'll see dark moving bands whipping across that sheet just before and just after totality. Also, Venus will be in the sky to entertain anybody that wants to look for Venus 15 degrees southeast of the sun. Now, here are my pinhole images of the sun. One lady had this hat, a woven hat, and through the holes, you could see all of these little suns peeking through it. It was really cool. And down below in center is a cheese grater or a vegetable grater. And people had these in Idaho for the last eclipse. They were trying to make America great again. And then finally, the leaves producing the shadows on the extreme right. It's really cool watching these little suns, all these little pinhole camera images of what's going on in the sky. If you're looking through the binoculars, you will see the pinkness of the prominences leaping off the sun, the red of the chromosphere just after Bailey's beads at C2, and then just before Bailey's beads at C3. And then, of course, the corona, it's always different from eclipse to eclipse, but it's spectacular. And just soak in that corona. It's such an incredible thing to see. So this is going back to the August 21st eclipse in 2017. And I hope many of you got the chances to see it. And this was the April 8th, 2023. It's so amazing how much that sun's corona changes from eclipse to eclipse. It's the magnetic field lines and different things that are emitting from the sun. It's just incredible. So to sum up, eclipses will take you all over the globe. You will see all kinds of interesting things while you're traveling the world. They take you places that you never thought you would go, and places that you will remember for the rest of your life. And also you'll meet interesting people. You see these people in airports, you get to know them after a while. You're walking from one terminal to another and you go, oh, that guy's carrying a tripod in that golf bag. I know where he's going. So it's really, really cool. And one of the things I always carry in my bags as I'm going to an eclipse is a bottle of champagne, because after a successful eclipse, it's wonderful to celebrate. And sometimes you lose. I've been to 12 eclipses. 10 of them were perfect. 2 of them were near Tahiti, and neither of them worked out. But I did see a corona in the Tahiti eclipse, and so I will end on that note. So thank you very much, and I'll pass it back.
Thanks a lot, Murray. That was very incredible as well. Thanks for teaching us all about eclipses. A lot of this stuff, even as a space enthusiast myself, I haven't, a lot of this stuff I've only been learning for the first time. So this is so interesting. Alrighty, so we do have one question, and the question is to both the speakers, and it is about whether the speakers would be willing to share their slides.
Yeah, absolutely.
Okay.
Although I will say that, as you saw in my slides, I use the pictures to tell a story. But certainly, I can put the URLs for the video I played and some of the cultural stories. One that I didn't share in the presentation, of course, was that blood red moon. Remember that blood red moon? And one of my favorite stories that I was hoping somebody would ask, what's my favorite story, other than this story of Rahu chasing or looking for the elixir of immortality, is for the ancient Incans, of course. They would see the blood red of a lunar eclipse, thinking that there was a jaguar on the prowl in some adjacent or nearby village and causing all kinds of destruction. And so their approach was, let's go outside and bang pots and pans and get the dogs to bark and make enough noise so that the jaguar would move on to another village or somewhere else, and of course not come to them where they are and devour them. And wouldn't you know it, they would do that and they would be fine, and the white of the moon would return, right? This science and physics in particular, of course, is the search for cause and effect, of trying to understand something, but these kind of correlations and stories that our ancestors created. I love this one of an ancient jaguar on the prowl and banging pots and pans and making noises.
Cool. Excellent. Yeah, I'm happy to share my slides as well. I will create a PowerPoint printout of them and make a PDF of it Good, cool.
Awesome, awesome. So is that able to be shared in the chat in the next few minutes, or will that be more of a something that we can add to the Space Place website? I guess we'll keep you guys updated on that.
Might be best on the Space Place because I can put up. I can also send a couple of PDFs if people want to make a pinhole projection or use the cereal box to make a pinhole projection or some activities if they wanted to do with kids. I think it's a cool thing to do.
Yeah, for sure. And we're just getting a message, so we can add it to the site and we can send it to individual attendees as well. So that's the latest update. Alrighty, so without further ado, thank you again incredibly for both of your talks. They were very interesting, and I'm sure on behalf of everybody watching, thanks again. I have a quick question actually. So is there anything else either of you want to say, any parting advice, any suggestions for somebody who wants to get started and doesn't know where to start?
And don't know where to start. Well, the first thing is to find out which one of these events, whether it's next Saturday, that's really close, of course, or the April 8th event is where can I go somewhere where I can see it. And so that's the first place to start. That Google map that's linked on the Astronomical Society of the Pacific's website, that might be a good place because you can scroll around in Google Maps to see where you want to go, or if you have family in different places, you want to know if they're on the path of totality, you can check that out. But then ask where to start, go and experience it, because it's one of those events, as Murray, who's seen 12 and can probably tell you all 12 because these are distinct memories that has created in his brain. These are incredible, momentous things that will last a lifetime. And if you have young kids or siblings or parents or relatives and you share it with your family, those are experiences that'll last a lifetime too. Just go.
Yes, and I'll second that, because the event is so majestic and it progresses along because it is huge. It is the way the cosmic wheel is turning, and there's no turning it back. You can't change anything. It's immutable. And you just watch this majestic progression of the moon covering the sun, and then this incredible view of this hidden world that you've never seen before. The corona, the prominences coming off the sun, it's all so majestic and it's pretty, it's beautiful. People have said, or I've said to a lot of people, it's like reading a book about, when you were a kid, reading about people falling in love and stuff like that. And I mean, it's something that it's outside of your experience. Well, looking at pictures of an eclipse is like that. Being under the eclipse is falling in love, and it is just superb. Yes, if you can get under the edge of totality and see the real totality, that's great. If you can't afford to get there, well, see that partial. It'll be a teaser that'll teach you a little bit about the cosmic connection between the Earth, the Moon, and the Sun. I think it's pretty wonderful. Anyway, back to you, Sky.
Sounds great. We are running a little bit over time, but there was one more question. We'll have that as our last question, and we will wrap it up. So our very last question is to both the speakers, and what is your favorite eclipse out of all that you've seen?
It's the last one.
Or the next one.
Always updates. All right. Good to know. So make sure to catch that eclipse on October 14th, if not the one in April of next year, and get started on your eclipse hunting journey. Also, before we wrap it up, please note that Murray has kindly provided a handout as well, which is supplementary to what he has just presented, a little bit, some notes on eclipses and interesting activities you can do around them. And instructions and links will be given in the chat. So it'll be on our website and in the chat. I will quickly share my screen and show you where it is. So if you go onto our site, here's kind of the visual in this green box. You can see the link for Murray's handout. And I want to tell you to check our website often to make sure you don't miss what's new. It's spaceplacecanada.ca. Also, be sure to follow us on social media, Instagram, X, Facebook, and LinkedIn, or you can subscribe to our YouTube channel right now. So without further ado, thank you for joining us today. It's been a real pleasure to learn and discover more about our solar system with such an enthusiastic and thought-provoking community. If you liked today's event, please give us a thumbs up and make sure to subscribe for more information on events like these, where we can deepen our knowledge together in a community setting. Quick note about sponsorships. With a donation of $40 and your home mailing address, we will send you our awesome and unique planetarium music card, which enables you to download the music from McLaughlin Planetarium, which closed in 1995. And at the $75 donation level and your mailing address anywhere in North America, you will also get a copy of An Earthling's Guide to Outer Space by Bob McDonald of CBC's Quirks and Quarks. It is also a very exciting time at Space Place. I can share with you that we're in the process of evaluating a potential physical location in downtown Toronto. Woohoo! So we are undertaking an engineering and architectural survey, and in light of these sponsorship options, we could really use your help to fund that. As I said before, I would encourage all participants today to get involved. Email us to inquire about our work, be a volunteer or apply to be a member. If you're looking to get involved in something cool and space related, there's an area for you, and we would love to have you join our team. But for now, thank you everyone, and see you next time.